I've been constantly aware of the irony that my entire career has been focused on automating my job away. Versus Salesforce, doing automated machine learning, we were automating everything that a data scientist could do. So feature engineering, sanity checking, everything that goes on to like training a model and hosting it for predictions was completely automated. And now at CueIn, like my job as a data scientist continues to shift and turn more and more into something where like even I get to experience the job uncertainty. Like, wait a minute, is my boss gonna replace me with a model? And
As
also,
long as they hallucinate, they won't.
yeah, just dumping LSD into the model, being like, do the work. You always want a human in the loop. And that is something I've been discovering more now, working with companies and having to spend so much time on really getting good labels and also being able to what the customer actually wants into labels and into a model. And that's even where I feel like my career is going. It's towards product and kind of being the human that's translating the other human to the machine.
Welcome to the Software Misadventures podcast. We are your hosts, Ronak and Guan. As engineers, we are interested in not just the technologies, but the people and the stories behind them. So, on this show, we try to scratch our own itch by sitting down with engineers, founders, and investors to chat about their path, lessons they have learned, and of course, the misadventures along the way.
Hi everyone, this is Guang. In this episode, we're chatting with Melissa about her unusual career journey in data science. We'll explore the lessons she's learned from automating away her jobs, transitioning from a lead data scientist at Salesforce to her current role focusing on chatbot observability at CueIn. Join us as we delve into Melissa's unique journey, what to do in the face of increasing job automation, and explore the latest developments in practical AI. Hi, Melissa. Okay, jumping right into it. So you have a PhD in computational neuroscience, and you study like single cell electrophysiology and
Yes, sir.
two photon calcium imaging in acute slice preparations that involves delicately removing mouse brains. Tell us more about that. Sounded very intriguing.
So, yeah, I did my PhD at University of Chicago, focusing on computational neuroscience. And I was studying information coding in the neocortex. So the neocortex is the part of the brain that I think is more exciting. Like when you just think of a human, you have all of these senses, all of the sensory information that you're processing and receiving. So your sensory information comes in through your eyes and your ears and your nose and your skin, and it gets relayed to the neocortex through a structure called the thalamus. And the pathway leading to the neocortex is fairly structured in the sense of like the responses of the neurons is fairly easy. It's very parallel to the stimulus itself. So it's pretty straightforward to decode what a stimulus is from the neural activity in these kind of earlier brain structures. But once it gets to the neocortex, it's where a lot of the interesting computation happens, and that's where all of our thinking happens, right? So that's where we're not only like flatly trying to perceive what's there, but we're perceiving it in a way that makes sense to us, in a way that can be incorporated with your other sensory perceptions, and then ultimately is going to lead to a thought or an action or a motor output. So we were really focused on understanding how groups of neurons in the neocortex encode information. And, all data science is like the data that you're looking at kind of changes how you view the system. So we had new technology. This is two photon calcium imaging that let us look at an entire field of neurons in relative real time. So you can see the action potential activity of neurons and you can see where they are in space. So that really allowed us to move beyond like traditional neural encoding methods where you're just looking at one single neuron spiking. And instead, we could look at the entire group of neurons and relate their activity to what the stimulus is, to like what computations are being performed and how those groups of neurons are representing the information. So I was in a pitch dark room because it was like imaging, right? Two photon with a big laser. pitch black, and like my lab, we love like listening to like hardcore metal or like death metal the whole time. Black hoodie, patching individual neurons with the microscope too. It was really fun stuff.
How did you guys analyze the data? Because he's going from analog to then digital and then
Mhm.
like,
Yeah, it depends on the recording method. So for two photon calcium imaging, the signal that you get is counting photons. Basically, so you're moving a laser beam around with these two mirrors, these Gavo mirrors. And because you are moving, you're controlling the mirrors, you know where the laser beam is pointed. So whenever the laser beam hits a certain specific spot, in three-dimensional space, you know where the laser beam is pointing. So any photons that you count at that moment in time, those photons are coming from one specific spot. So the input is coming in, as photon counts, but you're reconstructing that field of view. And the laser moves really, really fast. So you could cover like a millimeter surface area pretty quickly, like in a few seconds.
Comparing that to what you do now, how do these two worlds compare or contrast rather?
So now I'm on the founding team of a startup called CueIn. I think that the most biological aspect is just interacting with humans. That's where all the variability comes from, like understanding what customers want and how like translating that into labels. There are definitely a lot less mishaps in software as opposed to biology. By far, I would say that the more complicated that your system gets, the more opportunity there is for stuff to go wrong. Before QAnon, I was with Salesforce and I worked on a few different teams within Einstein. Salesforce Einstein is kind of like the catch all for machine learning at Salesforce. And I worked on the Einstein Platform. So we were building a machine learning platform, completely automated, multi tenant machine learning platform for all of Salesforce. And as that platform grew, there's just more and more components that can be misaligned or, not work. And that was actually more like science working on that platform because something would go wrong and you would truly not know why. Everyone had their own different expertise and things that they knew. So it's kind of like science in the sense of you have your tools and you're like sampling from these different dimensions to try to understand this like root phenomena, but you don't know if you're looking in the right place, if you're using the right tools. There's some uncertainty and some knowledge nuggets that you have to reveal through banging your head against the computer.
So you mentioned you're the founding data scientist or the machine learning engineer.
Mhm.
I get these titles confused and I don't know what the difference is between them, which is a different topic which we can get into.
Oh, yeah. So data science is more of a catch-all term. It usually involves that you're interacting more directly with the data, maybe working with scripts, prototyping, whereas machine learning engineer is like you're building software to scale up kind of what a data scientist does. I don't know if that's helpful.
No, that helps. So what's the founding story of QN? Like how did that happen to be?
So our CEO, his name is Mayuk Bao, and he was a product manager at Salesforce, and we overlapped sometime at Salesforce on the Einstein Platform. So him and his good friend Vinyesh Ganapathy, they both went to Stanford together and were good friends and always wanted to start a company together. Vinyesh was at Google and then later at Uber, leading engineering team, so very experienced in the engineering space. Bayuk was a product manager and he was working on Einstein bots. So during COVID times, unsurprising, bots got very popular. A lot of companies really needed to like spin up chatbots really, really fast. And Mayuk was with the group that was working with customers and setting up those bots. And he kept on kind of coming to a shortcoming and having the tools available on that platform that give customers both the observability and insight that they wanted into how their bots are performing and how customers were interacting with the bots, as well as like what can you do to make your bots better. Analytics can give you insight. You say, oh, this is where it's going wrong, but a company, you want to fix it. You want to fix it right away. So Mayuk saw that opportunity, investigated the market space more generally, and then him and Vignesh started QN, and Kevin joined as a founding data scientist. And It's been about 2 years since now our team is 7 people and we are so busy. It's really awesome. We have a lot of customers coming in and our use cases are just like growing. We're scaling up. It's a fun time.
Like from doing neuroscience to 7 years at Salesforce to now help founding a startup, like you must have some like perceptions about what building a startup is like. Were there any like big surprises that when you joined CueIn?
Good question. There weren't any big surprises. It was different for sure, but it was different in all the ways that I hoped it would be. I get to own like end-to-end solutions from like communicating to the customer, understanding what they want, developing the model and solution, exploring the data, getting a prototype model up for them, showing them the results, making sure they're happy, reaching out to the rest of our team and working with them to get the end result up to the UI and building the infrastructure around that, getting it into the database, getting it to the lambdas, making sure everything's working, and then like showing it to the customers and like doing all of this within like a month's time span, often even faster. Doing it all very, very quickly and getting that fast feedback. So that's like what I was hoping for. That's what I was looking for. I got it. And yeah, it's a lot of work, but it's definitely rewarding.
Uh,
Nice.
what did the process of making the decision look like? How did the founders of QN reached out to you to join, and then what made you actually take the decision to leave Salesforce and then join QN, which is again just 2 years in, so lots of risk of joining a startup, lots of excitement too, lots of adventures.
Hmm.
So, what did that decision making look like for you?
Good question. I think at the time when Mayuk approached me to join QN, I was actually really happy with my team, both horizontal and vertical. So it was, it was a little bittersweet to leave at that point in time where like things were going well and I just got my promotion and everyone was happy. But like sometimes you get an opportunity and you just have to go for it. For me, like I asked myself, like, what would I regret not doing this? And for me, usually the answer is yes. Like I would regret not having this experience. And like when I think of career path, I think I was at the point where like management was kind of more of like the next step for me if I really wanted to keep like growing. This is capitalism. It's all exponential growth. You can't just like have one derivative of improvement. So I was like, do I want to be a manager or do I want to have this new experience? And like, I knew it would be like a little bit of a pay cut, but it would put me in a place where like moving forward in my career, I think I would be doing more of what I wanted to be doing. Like everything's going well at QN. Like we're all very excited for like our equity to turn into like real money one day, but
Yeah.
the goal isn't really for me to like stop working. It's to be enjoying my job and to be able to have an impact, not only on the technology, but on the culture, on people's lives and experiences. For me, the point of getting power is to like make other people's lives better. Like that's what I like to do. I'm like, hey, we can all just be kind and nice and happy and do great, exciting work together. And that's kind of like what I prioritized and went for. And it's not hard for people to leave a corporation. I think everybody gets a little soul crushed in one way or another. So it was just time for a change.
So speaking of career path, when you first started at Salesforce, did you have like a rough idea of how try to climb the ladder and go for the how did you put it? No, first order derivative speed of growth?
Yeah.
Uh,
Exponential growth, Kwang.
Yeah.
Yes. Oh my gosh, physics. Sorry.
Extra kernels of growth.
And maybe another way of putting this is like two people, right? Like who are just starting their career, maybe in data science. Like,
Mhm.
would you recommend this sort of try to go for the exponential growth, but then at the same time, kind of keep an eye out for the startup opportunities, which are more of an unknown, right? Like, because you could
Mhm.
go really well, but you could also just go really horribly wrong, which I've
Yeah.
got plenty of stories about. So, like, how do you recommend newbies in data science, like, think about that?
Okay. Well, I'm going to start with your last statement about startups and kind of what I've heard from my network. It's either a really positive experience or it's absolutely terrible and traumatizing, and that, like, you need better help for, like, at least 2 years afterwards. And I think in making that decision, you really have to talk to the people on the team and really, like, get a good assessment of how happy they are and, like, what their mentality is. Are they there to grow and learn together as a team, or are they just trying to crush something out themselves? So for joining a startup, you really have to focus on the people and the culture and make sure that, like, you don't know if it's gonna succeed or not. The gods of stochasticity will decide that for you. Like, the only thing you're guaranteed to get from it is the experience that you get. So are you going to be doing stuff where you're growing technology-wise or growing new skill sets? And this is the case for any job, right? Like, you focus on, like, what skill sets you want to grow, and then also, like, ask yourself, "Is this an environment where I can grow?" Like, when I joined Salesforce, I really wanted to grow as a software engineer. Like, my background was comp neuro, so I was really like comfortable with reading manuscripts, like the foundation in mathematics and dynamics and optimization. And so I felt comfortable in the ML space and in kind of like the research space at the time. But like I've been programming in MATLAB for like 7 years, and I don't even know if you should put that on your resume sometimes. Like just tell
I
them,
Ouch.
empathize with that. I empathize with
Ouch.
that.
It's so
ouch.
beautiful though.
I really liked it. I had a lot of fun with MATLAB. I love building GUIs and
So
like
easy.
yeah, so easy. Parallel processing was just you ran out of RAM. So much. Anyways, I digress. So I had just kind of taught myself Python at the tail end of my postdoc and preparing for data science, but I was in San Francisco at the time and I thought like this is the time and place to learn how to be a software engineer. And this is like, especially with the team I was with that was building a machine learning platform, which was a very new thing at the time. I saw that as an opportunity to like gain knowledge that like wasn't knowledge you're going to get from a textbook or even maybe a Coursera. So that's kind of like the muscle that I wanted to grow. And I'm glad I made that investment. Of course, it does get to a certain point where you're like, okay, I miss data. I miss architecture and modeling too. But yeah, focus on where you want to grow.
And going back to the startups, if you were given two choices to join startup A, which has really, really fascinating tech, but then like the people aspect is like, it's like you get along with people, like it's versus startup B, but the tech is, maybe mediocre, but then the people are amazing. Which one
Mhm.
would you pick?
I think it really depends on where you are in your life and what's valuable. I think there are different times in life where you're like, I got energy, I'm going to conquer, I don't care about all that soft stuff and feelings, I'm just going to power it through. And there can be value in that until you're so miserable that like nothing's effective. But up until then, you can really grow just by like focusing on some technology that you're really passionate about. And there are different times in your life where, like, it's really important to just be stable and to be able to work 40 hours a week and not have extra stress. So, it kind of depends on where you are. I think having children is a big component, even though I have a 3 and a 5-year-old and I'm at a startup. But, like,
Was that Was that part of the calculation for you, for joining a startup is like, you feel like you've got a hang of the, small human being raising process that it's like, "Okay, now I can take some."
no, I'm totally contradicting myself. Life is crazy. But, I looked out with this startup because, like, I was excited about the tech. It was totally, like, my space, and I knew the people, or I knew some of the people, and I knew that they were really smart and really focused and, like, not petty or anything like that, and then so I was able to get both, so that's kind of why I went in that direction. Also, a lot of people on our team have young children, so I'm not the only one whose, like, meetings get crashed by, little bodies. It's pretty common, so that
Wonderful.
also helped.
Nice.
So you mentioned CueIn is in the space of customer experience transformation, which includes like chatbot observability. Can you talk more about this problem space and like what kind of products CueIn builds?
Yeah, so our more broadly, it's customer experience transformation, but I think you'll understand better once I describe kind of like our tech stack and process. So we pull data in, we build connectors to any vendor that a customer is using,
So
data from.
let's pause for a second. Let's take it for many people who might not know what customer experience here means, or like the
Oh, okay.
vendors that you work with. Would you mind just giving a brief description of what these terms mean?
Yeah, so customer experience is kind of like the evolution of customer support. I think customer support is kind of one component of it, but these are groups that are focused on the customer and the experience they have interacting with a company. So that includes communicating through a chatbot. It includes communicating with live agents through telephone conversations or through chat conversations, as well as email and asynchronous like ticket-based conversations.
Hmm.
So the typical use case is you have a retail company and people are reaching out to the retail company saying like, I want a refund, I want a return, this is too big, this is too small, this broke, what are your promotions, stuff like that.
Hmm.
Most companies have some form of customer support because they have a product and customers are using it and things break. So yeah, our goal is really to improve customer experience. And right now, really what companies are focusing on is we all have to do more with less. So everyone has less people, you have less engineers than you used to, you have less human agents that you can pay for. So everyone wants to automate more of the customer experience process, but they want to keep customer satisfaction, CSAT, NPS, which is like company net promoter score. They want to keep these metrics up while automating more of that customer experience. And they also want observability. And this is really where we come in is we connect all of the different channels and we offer like observability so you can see the entire customer journey from an individual customer to an aggregate, which is really what we focus
Hmm.
on, like grouping all of these different conversations in aggregate so you could see where things are going wrong and what agents are saying. So the use cases are pretty large and expansive. Our canonical use case is chatbot observability and optimization, like identifying where your chatbot is getting confused, where your customers are getting frustrated. So we identify those like missed intents when you have
Hmm.
like a traditional chatbot system is intent based. So basically, the bot has a concept of a list of intents, and those intents are mapped to a response. So the bot's job is to customer type something, you identify what the intent is, and then you provide a response. So you can imagine if the intent isn't already there in the chatbot system, it gets confused, either it misclassifies or it has like a I'm sorry, I'm confused response. And so we can identify those and we do unsupervised learning. So we identify new intents. And then we look at the agent side of the conversation because when a chatbot fails, it will usually it'll get escalated to a living human agent. And we look at all of those different agent responses, we summarize them, we aggregate them. So we could say, okay, and export both of those back to the bot. So we could say, here's a new intent. This is what customers are asking for. This is how your agents are responding. And they can look through the different kind of aggregated and summarized agent responses to choose the appropriate one that they want to use. And then you update your bot with that. So then you have a new response for the bot as well.
That's super interesting because observability in the machine learning context, right, usually is to help you build a better model, right? In terms of you
Hmm.
have better labels and then you clean it up. But then in this case, it can be like very different things, right? Like a large language model to something
Hmm.
that's like handcrafted by someone like sitting on the product side, trying to just figure out, hey, these are like the branches we want to draw. Is that like something that you guys experienced? How do you go about bridge between sort of all those different like types of levels of complexity, I guess?
Yeah. Okay. I think I get that. So you said a few things. One, you mentioned, using LLMs and bots, and that is a hot topic. So right now, I think where most of the industry is at is not letting a generative bot loose on their customers. That's something that people
That
are
makes
quite
sense.
apprehensive of.
Right.
It's also something that we, are moving forward towards, but like you have to set in a lot of guardrails and kind of like make sure that you have control over the responses. You're not giving misinformation or anything like that. So we as an industry do move more towards generative bots. Like the need for observability is even greater because like you probably don't want to release your new generative bot on all of your customers. You want to start, A/B testing with a small group. You want
Right.
to observe
Hmm.
and record what those questions are and what those bot responses are so that you can continuously build confidence in what you've built and then, expand it for more customers.
In this case, when you're looking at a bunch of this data coming from different models, and let's say in the specific case, it's just generative model on some slice of customers, other chatbots on other slice of customers. You mentioned you do unsupervised learning. I don't understand much about it, but what I understand is labeling data is helpful to recognize patterns and like train your models. Is that something that's done in this space, or you do, or is it all like
Yeah.
let the from the data figure out what makes sense?
Yeah, so our kind of ML stack is constantly evolving as all of them. I would say a year ago is much more founded in like traditional natural language understanding. When we analyze conversations, we do some supervised learning, so we categorize the conversation, like the different components. And by categorizing the utterances, that helps us simplify what a conversation kind of looks like so we can aggregate. And in that case, we supervise learning, so we do labeling. We do labeling internally and work with a team of labelers to make sure that we get these labels
Hmm.
correct. And then the unsupervised part that kind of that's some unsupervised, it's like clustering. Let's say you've got a bunch of utterances and you embed them using some embedding model like BERT, and then you're trying to like figure out what are these different groups. And it's always been a fuzzy process. You have different domains, you have different data sets, so you can kind of get an idea of like what is a good parameter space for you, but there's very much a human in the loop component of it. And when we do that human in the loop component, it's kind of fun. Like you iterate locally, you try different parameters, but ultimately I really try to make sure that I get the final result up in the UI,
Hmm.
not just, like, looking at spreadsheets, but I wanna see the decisions that I'm making with the machine learning models. I wanna see how this impacts what the customer is actually seeing, and then, like, what value the customer is getting from it. So, I think that, in general, is always important to have that human in the loop because we also get feedback from our customers too. Like,
Hmm.
we're a really agile team, so, like, we get feedback from them, we change it right away. Um, so yeah, when you're especially working in the unsupervised spaces, there's always going to be a human in the loop somewhere, and that's also something kind of we're working with companies in where we're like proposing new tags or new labels, and but they have a human in the loop that's like approving them or slightly modifying them so that it's kind of more consistent with the current taxonomy they have or something.
And the feedback loop here is that you made the changes to the system for the customer. Their CSAT or NPS goes up, and that tells you that the system's working. Or is there a different feedback loop in addition to
Oh,
this?
yeah. That's like the big loop. That's the big slow loop. The faster loop is taking their data and they say, okay, here's all of our conversations. And then we wave our machine learning magic wand and we put it up in the UI and it's all organized in a way that's supposed to be actionable and insightful for them. And they tell us what's useful, like what looks right, what is useful, what they'd like to see more of, taking in all of the knowledge and expertise that they have of their system and their business, and giving that feedback so that we can adjust it accordingly.
Is this online or is it like offline sort of batches? Like they give you guys the data and then you guys do sort of the analytics, or this is all happening within the platform, kind of real time?
Right now, most of it is in batch, meaning that like customers don't need to know like minute to minute what their CSAT score is.
Right. That
Yeah,
makes
so we do
sense.
it batch, everything's productionized. So in the sense of like we have an automated incremental pipeline. So once we've made all of our modeling decisions, and trained our models, then the incremental pipeline is running on its own. We do have one real-time feature, which is an answers API. I think this is something a lot of people in space are familiar with. A company has a bunch of knowledge articles or like all of their knowledge base, and they want to be able to just ask a question and then get a generated response from that knowledge base.
Yeah.
So, this is, I think, the direction people are thinking of going with bots. That's kind of where you want to go with bots, where you have your knowledge articles, and as long as you're updating them appropriately, you want someone to ask any question from the knowledge article and get a good response. So that's something we're doing right now. It's not being used for bots yet. We're using it for agents. So human agents, especially a new agent or really any of them, can just type in a question and get an answer. And that's a hosted API.
I see, I see. Like tying back to earlier where you said about LLM is way harder to implement as a chatbot for specific use cases for companies because
Mhm.
of the guardrails that you need. Like, do you see like a parallel between like now, even though the ideal would be something that's very flexible, that's LLM based, but when you are like looking at in practice, it's all like very much decision trees. Like
Mhm.
comparing that to back in 2008 or like when Hadoop and big data first became a thing, where like everybody's like talking about big data, just like now, right? Everybody's talking about LLM. But then you look under the hood, like nobody's actually like doing it. And I was wondering, like, do you see some like parallels of back then? Maybe it was like the complexity of infrastructure setup
Mhm.
that's sort of preventing people. Like, what do you think that is now that kind of prevents LLM adoption in like chatbots? Is it just like guardrails?
Yeah, that's a good question. I mean, that's always the case. It's so funny that you mentioned big data because nobody uses that term anymore. It's just data. It's all
it's
big.
it's all vague.
um, yeah, that's always the case. There's some new technology. It used to come from research. Now maybe it came from a company, and it does something that people weren't able to do before. But there are some kinks to be worked out, and some hesitation and caution, and the more like a company has to lose, the more risk adverse they're going to be, and the more time they're gonna take, and the more guardrails they're gonna set up. I think, in the LLM space, it's just gonna keep moving forward. I would be really surprised if in 10 years, like everyone wasn't using generative bots. I'd be like, that's weird. What happened? um, yeah, so I think it's just a matter of taking time and building trust. Like, with any new technology, you have to build that trust. You have to understand how it works. And if you don't understand it, at least see that it performs consistently enough where you're like, it's like physics, it just works.
So there is a case of using generative LLMs when it comes to chatbot itself.
Mhm.
You also see a lot of use cases these days, like people putting a bunch of small APIs on top of something like ChatGPT or other models where
Mhm.
upload an article or transcript of a conversation and we'll summarize it for you, or you can ask questions back and forth. Do you see opportunities of using LLMs in the observability side itself, where you have all this data, you have all these transcripts? Would you have an LLM summarize it and then work off of that, or that's just like no, don't do that because you can't trust the system enough to rely on it for observability?
Oh, we totally do. We totally use LLMs and everything. We just use them all the time. We host our own. We're fortunate enough to have. I was gonna say we're fortunate enough to have some amazing data scientists, but I realize being one of the three of those that like
You can still say that.
Kevin did most of the work in the recent LLMs. Kevin Moore and then Jasmine Wong, who's one of our newer hires, has been working on our LLMs. But yeah, we fine tune our own LLMs and host them. Different companies have different policies on where they want their data to go. Like some companies are okay with using OpenAI endpoints for like exploration and labeling. Uh, for me, I'm always worried about some other company hosting a live service, especially like I get a lot of emails from OpenAI saying something's down and degraded. Like I don't want my customers to have to suffer from
Yeah.
that. But yeah, we totally use it. I think they're really great in like early exploration. And like you said, summarizing, like by summarizing text data, like it kind of works as a normalization where like it's making the language more similar. So that makes it easier to cluster. And guardrails have to be in place. In general, what we find is hallucinations or what we call factual nonsense, which is a hallucination that sounds very reasonable. I guess you could call it like it's
Pseudo
talking out of its
profound
ass.
bullshit, you
I,
know?
I,
Like,
I forgot who said it, but it's like LLMs are bullshitters or professional bullshitters of sorts.
Professional bullshitters. Yeah, you gotta put your guardrails in place, and, like, it depends on what the problem space is you're working on. I think as soon as you've refined your problem space and you're working on one specific thing, it's pretty quick to build, like, confidence and, like, the responses are being generated and catching where there are errors and how you can fix that, which is usually providing more information or, like, better input data.
what do guardrails look like in this case? Because it's just internal, right? So you don't have to
Mhm.
worry about like prompt injection and things like that. So like, what do you have to do for the guardrails?
That's a lot of, like, you have a script, you've got your prompts, you're generating results, and then you look at the results. Like there's very much like a data scientist in the loop kind of reviewing things. And, of course you're writing scripts, so you're like grouping things and you're like, "Oh, that looks weird," and you dig into it. It was pretty easy to build like a hallucination detection, like classification model for one use case I was working on. Where it was just like a very or like specific use case and it was really obvious in the response that there were hallucinations happening. So it was, I got like 100 examples together and trained like a simple classifier and then hallucination detection. But it's easier to do the more constrained your problem space. Yeah, I think just really like nodding back to like observability. Like if you have observability, that is your guardrail where you can identify really quickly when something stands out, when something's an anomaly, and then investigate how to fix that, just like any bug.
And can you share with us like a little bit on the hardware side? Because recently I read something that there's like mod LLMs that's like compact enough that you can just like host it on like a single like video gaming GPU. What
Mhm.
what do you guys do?
We use AWS, like most
Okay.
startups. Yeah.
I see, I see.
Yeah, we have an
uh,
AWS stack. So we
Like
just spin up whatever we're like, like depending on the problem, the harder the problem, the more parameters you need, like the bigger GPU you need, the more money you pay. So
I see.
like try to use the small models for the small problems, and then big ones for the big ones.
this was a discussion we were having internally at one point. Many teams target to train X million, 100 billion, whatever number of parameter models and come up with numbers that keep growing. I mean, you keep seeing with all these new models coming out, oh, now we hit this new target. Oh, by the way, now there's a new target. How does one go about evaluating that there is enough ROI in that for the business? Like, yes, the model is better. How do you know if it's worth it for all the money you paid for the hardware?
Yeah. You always start small, right? I think for the bigger models, generalize better. They cover more use cases. If you're like thinking about constraints, like you ask yourself, is it cheaper to have like to train like to have five different like 7 billion parameter models versus like 100 million billion trillion parameter model is going to be a lot more expensive, especially for us where we have a lot of different like internal machine learning use cases to like build the model for the use case, and make it as light as you can without losing out in performance. And there's a lot of improvements and just like deltas on like quantization and different adapters that you can use as well so you don't have to retrain everything. There's been a lot of focus in that space as everyone's trying to get like the memory footprint down for these huge models.
As you build observability into these models, or in general, as chatbots improve, people start using more LLMs, they keep getting better. The number of human agents you have in the loop technically goes down. Essentially, what I'm getting at is many people have this fear that AI will result in many people losing jobs. What's your take on this as someone who's working in the space?
It's true. But people don't want jobs. They want money to live. This is something I empathize with, especially now, like economy has gone to crap and it's really hard for people to live. Like I have friends and family members whose jobs have been automated away, and it sucks. they don't miss talking on the phone to angry people all day. They miss like having a stable paycheck.
Hmm.
So I actually worked at a call center in college doing customer service for UPS. And like on one hand, it was the best job I had. Like I made $9 an hour, which was a lot of money back then because I'm old. And the people were nice, the managers were nice. You got breaks, but like it was so miserable. I dreaded every day because people were so mean.
Hmm.
Like, and I had different categories for the different types of ways that people were going to be mean. Like men tend to just like yell at you and then apologize, whereas women would kind of like get more personal until you
Oh, no.
cried. It was terrible. So like now it's funny because a large part of my job is like reading through these customer support transcripts and like I don't feel bad about automating this job. Like,
People could do better things with their time instead of being yelled at.
they really can.
Yeah, that is
Yeah.
so true.
And I don't think people are gonna miss these jobs. I think people want, they want stability so that they can live their lives. So like a part of it feels like, oh, maybe that's a cop out. Maybe I should take more responsibility. But also like I'm not the government. I feel like that's their job.
Hmm.
They're taking our money. They should help us be stable. They know we're
Yeah,
automating things. Yeah, it's always going to be the case, right? Industrial revolution, people left the fields. It'll just keep happening.
makes sense. I agree with that perspective. On similar lines, like as AI or these LLMs and other sorts of models help us become more efficient and automate things. What's your take on using LLMs for data labeling itself? Because if LLMs are able to understand data, could they also label it?
Yeah, they can.
Is that reliable
It's
or would
good.
that be reliable?
I would say anything that you're doing in an automated fashion, you need observability. So, like, can you just do it out of the box? Yeah, but you're not going to get very good labels. Yeah, we've definitely tried that. Like, doing labels, like, oh, let's see how these LLMs handle it. And then we're like, not so great. So, actually, a big focus of ours is like needing high quality labels that do require a human, and usually, like, lots of iterations of human, like, initial human labeling, and then it gets handed off to a data scientist like me, where I review it for consistency. You could train a model on your existing labels and then look at variability across different model trainings and try to understand like how consistent your labels are. And then go back to the humans and say, okay, these are the ones, this is how we need to change our rubric. This is how we need to change our process so that we can get more consistent labels. Yeah, so it's iterative.
So in 2017, you wrote a post about the future of commercial AI, where you highlighted like the key themes in that at the time. Since
Mhm.
we're talking about LLMs and AI, if you were to do the same for today, what would it look like?
Interesting. So one, that makes me feel really old because that was 6 years ago, and I thought it was just yesterday. Okay, yeah, it was the AI Frontiers 2017, and that was a really cool conference. It really pulled in a lot of people from just a lot of different big companies and small companies. So you had your big topics, which at the time was autonomous vehicles, and then also speech recognition. I like almost forgot that was like a big deal at the time. Like we can use deep learning for speech recognition. Like voice to text was not a given. Now we just kind of like take it for granted and like, yeah, maybe there are some nuance problems with specific systems, but you can get decent speech to text out of the box, especially if your audio quality is really good. Um what else were people talking about? Oh yeah, this was back when we were talking about when I say we, I mean like we as a field, moving from traditional feature engineering to just end to end just deep learning, just having a deep learning model handle it. And guess what? Deep learning won. Unless you have a really specific use case that you need like to hand engineer features because you want to control what those features are so that when you provide a prediction, you want to know exactly what those features were for the prediction. Like that would be a use case for hand feature engineering. But for the most part, we just let deep learning. handle.
But to caveat that, it's more for like big scale problem at like big companies, right? Like if you were to start something small, like you still wanna like handcraft your features, right?
Uh, not necessarily. Why not? Just like
Like if
I feel like now it's just like throwing out a big model, see how it does. If you don't like the results, then dig into them and like try something more traditional.
What you're saying sounds promising because the noobs like me can do machine learning. Like
Yeah.
throw stuff at the wall and see what sticks.
Yeah, see what sticks. You still have to dig in. It'll still give you nonsense if you're not careful.
Hmm.
I feel like that process has changed where it used to be like starting from the bottom and building something up, where
yeah.
now it's just like it's cheap and affordable and Hugging Face is awesome and you can just go on there and get a model and see how well it does on your data. And then if there are shortcomings, then you ask yourself, like, do I need to fine tune? Do I need to dig into the architecture? But most of the times, the issues are on the data side, like having enough data and having really good labels. Where, like, unless you really have like a specific use case, like, we're just really moving away from that traditional machine learning. And there are specific use cases that people have that we do want to use traditional machine learning for, but less and less these days.
Like, so to put it very concretely, like say, I'm finding this super interesting because I'm like starting to get like we were talking about. So say you're doing like fraud detection, right? Like, and like in finance, and then you have these sort of, I don't know, like 200,000 records of like based on like the different transactions that come through. And then you
Mhm.
have a set of labels of saying fraud or not fraud. So you're saying like basically we can get like say like even like an LLM, right? To and then just feed it through basically turning feature engineering to like prompt engineering and then
You
going
shot it.
to like right. And then it's like, hey, this is like the data that you're working with. So then whenever there's a new data point, and then you literally just, add it again, transform it to the prompt and asking the model again. It's like, hey, do you think this is a fraud or not? Like
Mhm.
that's like basically what you're describing, right?
Yeah, something you could do. If you're trying to just do a classification, you might want to go with just an encoder model. The decoder models that do generative are kind of more heavy. So yeah, you probably want to try a few different models, but I think usually that is a really good place to start. And you can iterate quickly and like even if it's not the final model that you use, you can get insight pretty quickly.
Interesting, interesting. Cool, cool, cool.
And yeah, like you don't need a ton of data to fine tune. Especially now that they have like adapters that are out there where you don't have to like tune all of the parameters of the model. You just have like a small subset of parameters that you're tuning for your use case.
I see. In that regard, almost like it is for like in terms of automation, right? Like it is automating even like some of the data science jobs, right? Because it's like if you
Not
can turn feature engineering into like prompt engineering, or well, I guess another way of putting it though is that it's kind of democratizing, right? Like the power that it harnesses, right? So like more and more have access to it
Mhm.
instead of right like you having to understand like all these sort of things. But then I guess the flip side of it is a lot of things can go wrong and you don't really understand how things work.
Mm.
And yeah, yeah, I see.
Yeah, you're always gonna want that specialist there when things don't work, who actually like goes in there and like can really like tear all the wires out and figure out what's wrong. But yeah, I've been constantly aware of the irony that my entire career has been focused on automating my job away. Like versus Salesforce, doing automated machine learning, we were automating everything that a data scientist could do. So feature engineering, sanity checking, everything that goes on to like training a model and hosting it for predictions was completely automated. And now at CueIn, like my job as a data scientist continues to shift and turn more and more into something where like even I get to experience the job uncertainty. Like, wait a minute, is my boss gonna replace me with a model? And
As
also,
long as they hallucinate, they won't.
yeah, just dumping LSD into the model, being like, do the work. Um, but
I
no,
mean,
there's always like I think gonna be you always a human in the loop. And that is something I've been discovering more now, working with companies and having to spend so much time on really getting good labels and also being able to what the customer actually wants into labels and into a model. And that's even where kind of I feel like my career is going. It's kind of going more towards product and kind of being the human that's translating the other human to the machine.
Hmm.
Which is cool, right? Like, we don't want to do engineering for the sake of engineering, right? Like, we want to do engineering for the sake of building better products.
And yeah, it depends. I know people
Uh,
who like to engineer for the sake of engineering.
I take that back. This is an engineering podcast. I take that back.
um, so you mentioned a couple of terms, and I've heard about those terms. I think I know them, but I'm pretty sure I don't. And I would love to get to know them from you. So you said something about few shot learning. What does that mean?
Shot means that you're just putting examples in your prompt.
I see. So you would, let's
Now
say,
I'm Googling it. I'm like, did I just brain fart? Wait, let me make sure. Yeah. Yeah, you put it in the prompt. Yep.
can you give an example of this?
So let's say I have a recording of, it's just a transcript of the conversation that we've been having. And I want to know when I told a joke that was funny.
Wow, this is all of a sudden very relevant. Please,
Yeah, it's very
starting to take
relevant.
notes. Please continue, Melissa.
So I want to know, yeah, when I said something that was funny. So I take the entire transcript and I put in the prompts like, when did Mel make a joke that was really funny and they weren't just laughing to be nice? And so, like, if you ask that, the model will kind of like do okay, but it'd be even better if I gave it some examples. So I would say, here are some examples, and I can provide the text of like when this is a positive example and it really was a funny joke, and this was a negative example where people were just uncomfortable and these were uncomfortable ha-has. And so you just put your labels there in the prompt, and you're restricted by the prompt size, so prompts can't be really big, so you want to kind of try to be concise as much as you can. And that's few shot. It works. I wouldn't build an entire product on it. It's a starting point, but it's not always great. You usually want to iterate.
What does iteration look like after something like this?
I mean, iteration largely is building up your labels and going from, like few shot to actual fine tuning. And fine tuning is, our traditional machine learning where you have your input and your desired output, and you train the model on lots of examples of those input output pairings, and then eventually the model figures out that relationship. So that's fine tuning, and you need more data for that. But that's going to give you obviously much, much better consistent performance.
Got it. And I have a couple more noob questions. So thanks for being so patient. So you mentioned Hugging Face. How do you use Hugging Face yourself?
It's a great place to just really quickly scope out the effort that will be involved in delivering a new product or a new aspect of the product. Um,
How so?
yeah, so let's say I actually did this back in the day before LLMs were like really big. I was trying to figure out how to extract root causes from conversations. And root cause is like a really specific kind of like concept. Like you want to know not just like what the customer wants, but like the why, like the underlying thing that happened. And this is very like, obviously LLMs are great at this now, but at the time they weren't really available. So I just went on Hugging Face and I got some QA models, and I felt so clever because I was like, we just need a QA model. We can ask a question and then we get the answer. And then I do like a bunch of like data processing and data cleaning and kind of moving some things around. And then, there we go. There we have our root causes. So that was an example where I just pulled a QA model, a question and answer model. Um, And that was like a fun way to it's funny because it was before prompt engineering, and that's kind of what I'm trying to do. Because like I didn't have time to like label 1,000 conversations or train people
Mhm.
to label 1,000 conversations. So yeah, I tried the QA model. And that comes up a lot where like somebody they want to know, oh, well, let's look at the sentiment. We're looking at CSAT, but I want to see how the sentiment of the user changes over time and how that's related to their ultimate customer satisfaction. So let's pull a sentiment model off of Hugging Face and like evaluate how well it performs and see if
Mm.
it can give us insight. And if we like it, then we can take it, pull it, set it up, make any changes or fine tuning that we want, and use it in our pipeline.
So Hugging Face is more like a repository of models that you can pick from with some
Yes.
indication about what the model does. I see.
Mhm.
Yeah, I was when I first looked at Hugging Face, I was a little confused about what the product was. Like I hadn't seen it until maybe early this year. Uh,
Okay.
and it had like a hosting API. It had this
Mhm.
repository of models. It has like a code space, some leaderboards. I'm like, I'm super confused as to what this thing is. I should ask someone who uses it to know what it actually is. So
Yeah,
thanks for sharing
definitely
that.
a repository of models, just like a really great knowledge base. You know what's funny is now that I'm thinking about it, Hugging Face is almost like turning into what OpenAI wanted to be when they started out. Like, do you guys remember when OpenAI was open and they had the reinforcement learning playground? It was all about like facilitating like learning about AI and making it like democratizing AI was like a hot term in the early 20
Hmm.
teens. And they had a reinforcement learning playground where people could test their different reinforcement learning algorithms and share them. Um, and it was really cool. I think they did a lot more like outreach and communications and saw them at talks and stuff. And then, things happen, capitalism happens, COVID happened, and then they started kind of focusing on these, privatized use cases, and now we have Hugging Face, which it's not like a reinforcement learning playground. I think it's even more, powerful than that because it's just like lots of machine learning models that you get to try out real quick and iterate, and the license is there. You know who wrote it. You can give homage to the authors.
Hmm. It's like GitHub
Right.
for ML models of sorts.
Absolutely, yeah, with some fun and bells and whistles.
Yes, a lot of Etzel missiles.
Right, now that I think of it, OpenAI had the Dota competition thing, right? Like that they were doing like RL with like different video games and trying
Yeah.
to right. Wow, it's very different now. You're right. Yeah.
Yeah.
By the way, for folks who are new like myself and who maybe want to learn more or play around with some of these models, do you have any recommendations for a place to start? Like, hey, go do this course or something, some posts or blogs that you came across which are helpful?
I think that I'm gonna give the advice that, like, I think is pretty canon or, like, a lot of people give is just, like, start getting your hands wet right away. I think courses can be helpful for people, especially if they don't have, like, engineering
Hmm.
experience. It's hard to get off the ground when you, like, can't install Python. Like, it's very frustrating, but, like, I if you have, like, some, like, basic engineering skills, I really recommend just getting your hands wet. People, traditionally for data science, people used to say go to Kaggle. Kaggle like hosts data sets and competitions, and it was a place where you could go to get data to play around with. Um, but now, honestly, I recommend that people check out Upwork. So Upwork is a company where like companies can hire people as contractors for different tasks. And one of those tasks can be data analysis, machine learning. So Upwork, I think, is a good place to hone a new skill. And like you're motivated because like companies will post different jobs. So you can see like what a company wants to do and you can do whatever like their take home interview, see how well you're doing and see what like people are actually hiring for. And this is what you used to only be able to do by like going through the grueling process of like applying to a bunch of companies and hoping that they like this is what before I started Insight, this is kind of how I got started doing real data science is like getting a job interview at a company like Uber, Facebook, and failing miserably and then going back and resolving that problem and being like, okay, now I can do this. So like now you can do it through Upwork, and like you can, I think it's less soul crushing maybe than having to like get all excited about working for a big company and realizing that you're not there yet.
Yeah. That's good
It's
advice.
very relatable. Yep. Cool. So we want to be respectful of your time. Sorry that we're already going over, Melissa, but maybe the last question. So like, suppose you had the power to send a tweet that everyone will see. What would your 280 character message say?
Stop using Twitter.
Damn. Uh,
Ah.
you got us there.
We need a better question.
Yeah. Oh man. Like well, to stay on theme with the LLM, we actually use the LLM to come up with a question like this, that sounds somewhat reasonable. And I guess in also a very LLM fashion that, it could lead to hilarious failures. Anything else that you would like to share with our listeners before we close off?
No. Be kind. Kindness is free. Kind to each other. Kind to your bots. Some people think that one day they will rule the earth and they have all the data, so be polite.
Awesome. Thanks so much, Melissa.
Thanks for taking the
guys.
mind,
coming on the
Melissa.
show.
Yeah, it was a lot of fun. Thanks for having me.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.